Neurons, like all living cells, are surrounded by a plasma membrane that is impermeable to ions. This property allows a neuron to maintain different concentrations of ions between the inside and outside of the cell. In a typical mammalian neuron, there is a large difference in the concentration of ions, such as sodium and potassium, between the intracellular and the extracellular environments. In addition, the interior of the neuron has a high concentration of organic anions, including proteins and nucleic acids. The plasma membrane is composed of a lipid bilayer. Its hydrophobic nature prevents the diffusion of ions across the membrane. The only way ions can diffuse across the lipid bilayer is by passing through specialized channels. These channels are transmembrane pores that permit the movement of particular ions while excluding others. Such channels can be in an open or closed state. When a neuron is at rest, most ion channels are closed. However, some potassium channels are open, permitting potassium ions to diffuse out of the cell down their concentration gradient. Note that sodium channels are normally closed, and thus sodium ions cannot cross the membrane when the neuron is at rest. In a typical neuron, the internal concentration of potassium is higher than the external concentration. Two opposing forces influence the movement of potassium ions. First, a diffusion force drives potassium ions down their concentration gradient towards the exterior of the cell. The movement of potassium ions out of the cell increases the internal negative charge. The positively charged potassium ions are attracted to the internal negative charge, and this electrical force pulls potassium ions back into the cell. The diffusion and electrical forces eventually come into balance, and an electrical potential or voltage is reached, at which the electrical force exactly balances the diffusion force. At this point, there is no net movement of potassium ions into or out of the cell. The electrical potential across the membrane can be measured by inserting an electrode into the cell. A neuron at rest has a voltage difference of about -60 millivolts across the membrane. This value is the neuron's resting membrane potential and is governed by the relative concentrations of ion species between the intracellular and extracellular space.